At this point, if I can make a suggestion, I would get a sheet of paper and a pencil, or maybe a couple of sheets of paper, because a lot of the rest of this unit deals with trying to draw things out, trying to draw attachments between atoms. And I'm going to give you the opportunity to pause. I will ask a bunch of questions throughout the rest of this unit, and you can basically pause at various points and try to sketch out the types of things that we're talking about. So in this section, I am going to talk about two rules for attaching carbon and hydrogen to each other. And by using those two rules and sort of following those two rules, we can see how certain molecules have their atoms attached to each other. So the first rule is this: carbon atoms always make 4 covalent bonds. Now, that's not completely true, but it is almost always true. And for our purposes, we're going to treat it as always true. So rule number 1, carbon atoms always make 4 covalent bonds. They don't make 3, they don't make 5. They will always make 4. The next rule, and this is the only other rule that we're going to talk about today, well, that's not completely true. This is the only other rule that we're going to talk about that deals with the numbers of attachments that atoms make. The second rule is this: hydrogen atoms always make 1 covalent bond. They don't make 0, they don't make 2, they only make 1. So here are 2 rules: carbon 4 covalent bonds, hydrogen 1 covalent bond. If I told you those 2 rules, and this is where the sheet of paper may come in handy, if I told you that I had a molecule, and the formula for the molecule is Ch4, and I wanted you to sketch out how those atoms are attached to each other. So this H4 means that there are 4 hydrogen atoms, and the C with no subscript, no number in the lower right here, means that there's only 1 carbon atom. If I told you that you were working with this molecule, and I said, look, how are these atoms actually covalently attached to each other? And you could basically follow these 2 rules and figure that out. So if you want to, you can pause at this point and sketch it out, and I'll show you the answer in a moment. The answer is this: you have to have the carbon atom in the center, and there have to be the 4 hydrogen atoms attached to this 1 carbon atom. So the hydrogen atoms are basically spread out from the carbon atom. And this is the only way that you can draw all of the attachments and satisfy this top rule here and this other rule for the hydrogens. So if you look, every single hydrogen is only making 1 covalent bond. This hydrogen here, 1 bond. This hydrogen here, 1 bond, and the same for these other 2 hydrogens over here. And so those hydrogens are all behaving according to this rule. This carbon here, this carbon right here, is also satisfying this rule up here. It is making 4 covalent bonds, 1 to each of the hydrogens. 1, 2, 3, 4. So it turns out that if I told you you were working with this molecule, and this molecule had the formula of CH4, this is the only way that the atoms in this molecule can be attached to each other and satisfy both of these rules. So if I told you you're working with CH4, this is the only way that you could actually draw the attachments and have it be a correct set of attachments. So just to show you an example of a wrong way to draw the attachments, the CH4 molecule cannot be like this. It cannot have these types of attachments. If you look, there are 2 rules being broken. This carbon atom over here is only making 3 covalent bonds, 1, 2, 3. And this hydrogen over here is making 2 covalent bonds, and it's only supposed to be making 1. This hydrogen is making 1, 2 covalent bonds. So just by following these 2 rules, carbon always makes 4 covalent bonds, hydrogen always makes 1, you know that this cannot possibly be the case. If you work this out on pencil and paper, and it may not have been obvious to you the first time doing this, but I'm going to ask you to do this a number of times, this is the only possible way of making the attachments. And these rules, carbon makes 4 covalent bonds and hydrogen makes 1 covalent bond, these rules actually come about from something that we discussed much earlier in the course when I was describing valence shells and electron shells and how the atoms prefer to have their outermost shell filled all the time. And you will see that carbon atoms, a neutrally charged carbon atom, has 4 empty slots in in its outermost shell, and because it has 4 empty slots, it has the ability to make four pairs of shared electrons, which means 4 covalent bonds. And hydrogen has 1 empty slot in its outermost shell if it's neutrally charged, which means that hydrogen can make 1 covalent bond. So these rules are not just rules that somebody made up. They come about from the types of topics that we talked about much earlier in this course. But if it helps you just to sort of keep these rules in mind without going back to valence electrons, that's perfectly fine. Just keep in mind, and we're going to talk about this throughout this unit, carbon always makes 4 bonds, hydrogen always makes 1 bond. And this is the only way that you can attach the atoms for the molecule which has a formula of CH4 and meet both of those rules. Here's another one that you can pause and think about. If I told you that I was working with a molecule and the formula was C2H4, what is the only way that you can draw the atoms here, 2 carbons and 4 hydrogens, and satisfy both of these rules? You can pause at any point and work that out. Turns out that this is the only way that you can draw those atoms attached to each other and meet both of the rules. All the carbons have 4 bonds. Here's carbon number 1. It has 1, 2, 3, 4 covalent bonds. The same for this carbon. This carbon has 1, 2, 3, 4 covalent bonds. And then each individual hydrogen has only 1 bond to one of the carbons. So again, if I told you you're working with a molecule that has this chemical formula, this is actually this is a cartoon representation of what that molecule looks like. This is the only way that you can draw the atoms attached to each other and meet both of the rules that we described above. Here's another molecule. Imagine that I came up to you and said, look, I'm working with this molecule, the formula is C2H2, and I asked you, how are the atoms in this molecule actually attached to each other? Again, you can pause, we'll be doing this a fair amount, and you can try to draw the attachments and satisfy both of those rules. The only way that you can draw 2 carbons and 2 hydrogens and satisfy both of the rules is to make a triple covalent bond between the 2 carbons. This carbon here has 1, 2, 3, 4 covalent bonds. The same with this carbon, 1, 2, 3, and a 4th covalent bond here, and both of the hydrogens are only making 1 covalent bond. So this is the only way that you can draw this particular molecule here and show the correct attachments. It turns out that there's no other way to do it. So this is sort of an introduction into how organic molecules are attached to each other. As you can see, every molecule here is an organic molecule. It contains carbon. It also contains a fair amount of hydrogen atoms, as I mentioned in one of the earlier slides. And just to point out here, a large portion of organic chemistry is devoted to studying what's called the structure of organic molecules. So I wrote here CH4 structure. Structure is basically the chemist's formal term for describing how the atoms in a molecule are actually attached to each other. So the structure of this CH4 molecule is shown in cartoon form here. The structure of this C2H4 molecule is shown in this cartoon form like this, and the same thing for C2H2. And the other thing to mention is that a large portion of organic chemistry is devoted to studying how atoms in organic molecules are actually attached to each other. Because even though this molecule here may look a fair amount like this molecule here, they both have carbons and hydrogens, it turns out that the way the atoms are attached to each other can have significant effects on how the molecules behave. So this is made of carbons and hydrogens, so is this one, but they are completely different molecules because of the way the atoms are attached to each other. The other thing to point out is that I have drawn the CH4 molecule over here, and it has a different name, which we'll get to in a little bit. I've drawn the CH4 molecule as kind of this flat molecule. It sort of looks just like it would just lay flat on a sheet of paper. In real life, these molecules, all of these, have very specific shapes. And it turns out that the CH4 molecule in chemistry, you say that it has a tetrahedral shape, which just means that it's kind of shaped like a pyramid. It's not actually flat like I've drawn up here. It actually is shaped like a pyramid where the carbon is in the center and the hydrogens are basically corners of a pyramid. You don't need to know this angle here. That's not really important for our studies. But I want you to realize that even though we're going to draw all of these molecules pretty much flat, they actually do have three-dimensional shapes.